Hello, I'm Joe Shaw. I'm a full stack engineer in the Incubation engineering department at GitLab. And my focus is on application performance monitoring and how we take that idea and build our own solution for it. So what I'm going to show you, as you can see now, is an issue for my weekly demo. It's a fairly quick one this week. I've been out a couple of days and I've been doing a lot of useful Postgres training as well, which has been very handy for this work actually. So I've been doing a bit of Postgres work with timescale DB. So as I mentioned in the last video, I'm currently evaluating ClickHouse as a back-end database for observability data for a number of reasons. So I'll just go through to the issue here we've got for the evaluation. So there's a few links in there for anyone that's interested. And what we've started looking at is benchmarking ClickHouse against a few different databases that are prominent in this area, and particularly ones that are supported by the time series benchmark suite, which I think I discussed previously, a project created by, I think, InfluxDB and now maintained by timescale.db. And here's a breakdown that you can see of all the supported databases in that benchmarking tool that you can run against. And the tool supports a variety of workloads. The one we're interested in is a DevOps workload. So it will simulate metrics for CPU, disk, memory, kernel metrics, all sorts of stuff like that, and give you quite a few tables there. And the benchmarker that they have will set up the database, create the tables, simulate data, set up workers to insert that data, and it also creates a bunch of different varying queries in terms of complexity, from basic selects through to quite complex group by operations as well. And I will document all those queries in here as well once I've done the analysis. So of this sort of matrix I've set up here, what we're looking for is a database that is multi-model. So it's not just time series, because we want to use this data store for other observability data as well. So we want it to be able to handle things like traces and complex data structures like that. We really need replication, probably partitioning as well as things scale up. We want at least a medium to high query flexibility. So what I'm talking about there is, sort of how complicated the queries you can write. You do complex groups and joins and things like that, and a level of maturity. And I've really based that on how long the project has been running, the amount of traction, things like likes on the repository code, and discussion on Stack Overflow and things like that as well. So you can see from that grid, a few stand out, ClickHouse being one of them that we're interested in, CreateDB, another, MongoDB, and of course timescale.db. And timescale itself is metrics focused in terms of time series, but it is multimodal because it's sat on top of Postgres. Okay, so you can put anything you can put in the Postgres database in there. MongoDB, JSON store database, very flexible, so we'll see how that performs. CreateDB is one I'm less familiar with, but it does claim to be multimodal, so I'm just going to keep that in there for the time being. The other ones I've excluded for that reason, and levels of maturity and stuff like that. So I'm just working through a checklist now, and we're using the time series benchmark suite here that we forked from the original one, from timescale, and things that we've changed in there. We've got our own evaluation script, which just utilizes all the built-in scripts. I've had to make some tweaks and fixes and some slight modifications to get it working the way I want. That orchestrates for the number of databases, the load, the setup, number of workers, things like that. Docker Compose there, that sets everything up. So again, we're running it in Docker. My thinking behind this is just keeps it simple, but also it's containerized, which is how we would be running it in production anyway. So there's a few databases that I'm setting up there, and it will bring these up one at a time. I have a Prometheus and CAdvisor running to collect general background and container metrics. If you're not familiar with CAdvisor, it's what is used in the kubelet in Kubernetes to collect pod metrics in there. And the runner itself is containerized as well and orchestrates the rest. So that just makes it simple to run. We can override these environment variables and control that. In terms of the data that we have there, just quickly showing you, it spits out a lot of these data files here for different runs, different queries. If we just have a look in one of these, this is a ClickHouse, gives you a brief, very simple description of the query, double group by all. I haven't looked at that query yet, so I'm not sure what it's doing. Some information about the run, duration, and you've got percentiles in there, which is very useful. So we'll probably look at sort of 95th percentile for evaluating, for comparing, which is fairly typical, and a query rate throughput there as well. So what I want to do with this is just write a quick script, maybe Python notebook, something like that, that will get all these and make some graphs so we can do a quick comparison with them all. And then after that, what we're wanting to do, back on here, let me find the issue, do run that comparison initially just between timescale and ClickHouse. Timescale is the only other sort of obvious candidate. And then create DB and Mongo in there as well to make sure we've covered some obvious choices, and we can sort of back up any decision we make, and make sure we analyze CPU, memory, and disk usage for each one as well, and present a comparison in this issue. And then hopefully I can make a sensible choice based on that, and we can start building the first iteration. Okay, that's all for me this week. Thank you for watching.